Hello there everyone, and welcome to this workshop on data engineering with Python and Redis. My name is Valentine and I'll be instructor. In this workshop we are going to be going through these following steps. So we will start off by getting to learn about the learning outcomes. These are the objectives of the session. After that we'll get to talk about what data engineering with Redis entails, why we would want to learn about it and also use the concepts in our line of work as data engineers or data professionals. Then after that, we'll go into a practice session where we'll get to practice various data engineering with Python and Redis concepts. So essentially build a data pipeline and get to work with the data pipeline itself. Then towards the end, we just talk about what next after this session. So let's get started. By the end of today, we are expected to have achieved these learning outcomes. So we should be able to recall the key concepts in data engineering and how Python and Redis can be used to construct and optimize data pipelines for generally efficient data management and processing. We should also be able to design ETL or extract, transform, and load data pipelines that would be essential in automation as well as transformation tasks concerning generally data. We should also be able to use again Python and Redis just to be able to manage lots of data because Redis comes in really handy, especially when you have lots of data. And lastly, we should be able to evaluate and troubleshoot data pipelines involving the use of Redis. And the idea is just to have a reliable product at the very end. So what is data engineering with Python as well as Redis? So this just involves the process of using the Python programming language as well as this database called database or data source called Redis, and the idea is to be able to use both to create these programs that we call data pipelines that allow us to extract data from various sources, transform the data, as well as load that data in some destination data source where stakeholders such as data engineers or data scientists might be able to use. Generally, Redis is one of the many data sources that we can use. In the past, if you follow us, we in our YouTube channel as well as also on Meetup and Eventbrite, we have also covered sessions where we take on technologies in relation to relational databases where we store data in a tabular format. In other cases, we've gotten to have explored how to work with NoSQL databases where we do not store data in tabular format, but we store unstructured data in a type of databases called NoSQL, and one of them being MongoDB. Redis isn't like those types of databases that I've mentioned. Redis is different. With Redis, we can be able to store data in the form of either strings, lists, sets, or sorted sets, or even what are called hashes. And the idea could be, you might want to just temporarily store data within that storage and be able to then retrieve it later for different cases. So one of the most popular cases for Redis is caching. So we might store data that we would normally frequently access. So instead, assuming that you have a data pipeline that collects data from maybe a MySQL database, and that data doesn't change a whole lot, and assuming you're also getting some data maybe from another database, maybe some a MongoDB database, and assuming that data changes a lot. If you wanted to create a data pipeline that gets data, let's say from MySQL and MongoDB, you could decide to implement some code that also, once you get data, say from MySQL database, the database that doesn't change a lot, you store it in Redis. Still during the data extraction phase. Then from Redis, every time that you are running a pipeline or the pipeline that you're building, instead of getting data from MySQL, the data that isn't frequently accessed or that doesn't change a lot, instead of getting it directly from MySQL, you still just pull it from Redis because you've cached data, you've temporarily stored data that you frequently need. But that data does not necessarily change a lot. And then you can be just getting this other data that you get from MongoDB as frequent as possible. So Redis would act more like a layer between, say, your data pipeline as well as your MySQL database. And it just helps you to be able to reduce the computational resources that allow you to, that essentially would be expensive if you were to directly get data from the original sources. So generally in such a situation, you'd have Redis acting as a caching solution. In some cases, you might also want just to store data as just to store just data in Redis. You know, in some cases, you might build a data pipeline that just gets data from a Redis data source. That data might be data that you stored in the form of a list. This is just a collection of data that is related. It could be maybe, for the simplest case, it could be maybe names of persons. You just collect that data and use it somehow. Maybe it might have been stored there by another particular data pipeline that efficiently did some sort of processing and extracted data somewhere and put that data in a Redis instance. And that would mean that you would be in a position to just pull that data. So again, you can use Redis for data storage. And lastly, session management. This is normally the case where you're working with web applications. Our focus won't be so much on this side of things. This is something that web developers or software engineers might want to focus so much on. But again, if you're versed in how to work with Python, using Redis again with Python for this specific use case, say web applications, may not be that much different. The only thing is that the context might be in a web application framework such as Python, such as maybe Django, or another solution, maybe Flask also. But our focus will be on the caching end as well as the data storage end, because again, the reason why we would be watching this and we would be following through this workshop would be because we want to learn more about how to become a data or equipped data professional in the long run. So again, generally, just to recap, why would we want to use Redis? Redis generally allows us to improve the performance of our applications, whether it's, you know, just the data pipeline or even just a script that you're working with. When you combine Python with Redis, you're able to significantly enhance the performance of your data pipeline, because again, you don't keep on getting data from the original data source. You have it stored somewhere that you can frequently access. Scalability. When you're handling large data sets, Redis has been designed such that you can be able to scale your solution easily. So again, when you implement Redis within your application, you actually tend to make your data pipeline much more scalable than it was if you were to be every now and then just getting data from the original data sources. As you know, you would traditionally. Lastly, flexibility. When you use Redis, you can store different types of data as well as work with different Python libraries. You might realize the concepts that we're going to be covering are quite basic, because we are helping you to just build this knowledge. But as time goes on, you might realize that you could use Redis with some advanced data manipulation libraries. For our case, we're going to be using Redis with pandas, but in some cases you might realize, maybe using a data processing tool that is much scalable, or that helps us to be able to perform maybe some sort of large-scale processing would be important. Maybe you might decide to use the Python varx library that works really well with large data sets, or even PySpark. Again, when you work with Redis as well as Python, you have vast possibilities at your disposal. And so why you would want to use Python and Redis? Performance, scalability, and flexibility. Why not? Why wouldn't you want to use the two? I think one of the things would be if your solution is actually solving the original problem, you may not necessarily need to. But again, if you get to a point where the research problem changes into now one that requires performance, then you can think about now incorporating Redis. Again, there's also the idea of complexity when it comes to setting up, and also time that you spend when you are building your solution or your data pipeline. So that is also something else that you ought to take into account. All right, so at this particular point, we're going to move on into our practice work. The first thing that you need to do is just visit the practice resource link at the description section of this video. And at some point, if you realize that you're getting lost, feel free to pause the stream and just rewind it. And you could always just quickly catch up. Again, always feel free to pause the stream or the video. So yeah, click on that link and it should take you to a page that looks like this. And once you get here, you need to click on the sample practice resource. So click on this link and you should again be redirected to what you're seeing on your screen. Once you get here, you need to save a copy of this notebook. So go to File, then save a copy so that you have your own copy and can be able to make changes to it. And yeah, so once you do that, then we can get started. I'll be using a practice notebook, not the sample notebook. The practice notebook is the one that we provided to Afterwork members. By the way, you could always feel free to become an Afterwork member. It will help in just being able to get all the resources that you need. So again, it's just similar to the sample notebook. The only difference is that there are more challenges in this notebook. I'll be having mine in playground mode, but once you've saved your sample in a new, once you saved a copy, it should open a new tab. Just open the new tab one and you should be good to go. So once you have your copy of your sample notebook, you need to click on connect. It might take a few seconds to connect the notebook to Google service, then we can get started. Okay, all right, we are connected. Now let's go through the prerequisites. So to work with Redis, Redis is a data source by itself. It's like more of what you have, maybe MySQL, MongoDB, Cassandra, etc. To be able to work with Redis, you need to, again, with now Python, you need to install a library that allows you, or some chunk of code that has been written by experts or other Python developers that allows you to interact with now Redis. So we would need to install the Redis library so we can run the first code cell, and that's going to just install Redis, which is the library that we're going to use to connect to our instance, to a Redis instance. It could be local, but for our case, we'll create one in the cloud. So now, once we have done that, we need to import it. Once we've installed it, import it. And then the next thing, we need to also import pandas for data manipulation. Right, so once we have done this, the next thing that we need to do is to click on this link. I think I had written it as shown here, but I think we can just click on that. It's a download link, but yes, you can just click on that link. It should take you to a page that looks like this. So we're going to be creating our Redis database on the cloud, and we're going to be using a service that is provided by the creators of Redis or the maintainers of Redis, and this, what we're going to be using is a free solution. We won't use yes, you are free to continue exploring how you can be able to use a commercial solution, but for our case, we're just learning, so we're going to be using what we have here, and it should be sufficient enough for this section, and we should be able to just get to see how we can interact with Redis. So once you get here, you can sign in with any, but you don't need to write all of this information. Just click on any, like Google, just sign in with Google. Just click on this icon, the Google icon, and once you've done that, go through the initial steps. You'll then end up to maybe some page that looks like this. I hope it does. If it doesn't, then it should. But again, I'll just click on, if it gets to this page, just click on databases. If you don't get to this page, once you've logged in, just click on to the far end, that's databases, then click on new database. And then it should just load what you're seeing on your screen. So we're going to set up a Redis instance altogether. Maybe initially when you log in, it will give you something like this, which is still okay. But again, you could always just click databases and it should take you to now this page. Now, you're going to be using Redis for caching data, not really so much of as a database. So our focus will be just to cache data. So we can name our database. So over here in this section, we are not going to, don't click on any, just click, if this is selected, just click on the essentials option, then database, just write learning. We don't need to set up anything else. Here, just click on 30 MB. These are other storages sizes that you might want to explore, but not now. Then click on create database at the very bottom. I think on my screen, if let me take it, nope, let me move my screen a bit higher. So there's create database over here. Just click on create database. All right, so it usually takes a few seconds or so to set up your database. But now, if you look around, you'll see that this is the database name, and one is that, but actually it has been created. And there's the public endpoint. We're also going to need this, and so there's some more information of what we need. Over here, we also have a default user and password, etc. We can change it if you want, but to connect, we need to go, you see where it's written public endpoint. We need to collect, or we need that code for this. So we click on the far right. There's the connect button on the far right so on this line on the far right, there's a connect button. So click on that. You should see a pop-up, and then click on Redis client. My screen is just over there, but when you click on Redis client, you should see what you're seeing, and then select Python. Once you see that, just copy the code that you have here, or just copy this particular bit, copy this code and paste it somewhere. Just copy that and paste it somewhere in your computer, maybe in a notepad somewhere. We're going to need that. So just paste it that, and that will contain just the information that you need when it comes to connecting. That's actually what you need. So you could even just now leave alone the entire platform, Redis platform, because already we have created a database. But if you want to just to explore some few things, you can just explore. Just click on all databases. This is, you can see how many databases that you have here. Then click on learning. It will just take you back. There's metrics. You can just explore a few other things. It will maybe take a bit of some time. There's some log information, but essentially, we have our database already set up. If you wanted to delete it, you just scroll down and just say delete database. And this is free for now because you're not charged for just the learning bit. Yeah, right. Let's now move on to now our Python sample notebook. I'll use my practice notebook, and we'll continue now working with Python and Redis. So the approach that we are going to take here is that we are going to first of all learn how to work with Python and Redis. Once we've gotten to have achieved that, then we'll get to learn how to create data pipelines with Python as well as with Redis. So working with Python and Redis, so let's learn how to connect. So we'll learn how to connect to Redis, how to store data using this type of data structure, string, sets, then hashes. There are others, we may not extensively learn about them, like lists or sorted sets. We won't learn about them. This is just for ease of understanding how we can use these concepts when it comes to creation of data pipelines. Right. So let's let's go here, connecting to Redis. So what I'm going to do is to copy the code. Remember that code I told you to copy, and it's in your computer. Just copy it and replace it with what you're seeing here. If you try to run what you're seeing here, it will give you an error because the instance doesn't exist. I deleted it earlier. So paste it and also your password. So oops, you need now to go back to, I've pasted it. We need now to go to our database and get our password. So scroll down and you can copy it. Then once you copy, you go to this case over here, paste it here, and then run it. That's what you need. Pause the video and do that. Once you see a check, we should be good to go. All right, moving on. By the way, the challenge just requires you to connect to your own server. So you can it's actually the same thing. You could do what we have done here. All right, the next thing that we need to do is to now learn how to store data using this data structure called a string. So you're going to learn how to perform what are called CRUD or CRUD operations. So how to create a string, how to read a string, how to update and delete a string. So when it comes to Redis, we can store data in what is called a key value format. So it's more like what you have in dictionaries. You have a key and a value. So assuming in this case, we might have maybe a product name. This might just represent a product name. This is the key and the name of the actual product. Could be maybe fruit, then banana, whatever that you have or whatever. So to be able to now store data in our Redis database, we can store it as a key value. So we can say we use the R set. So in Redis, they're usually what are called commands. Yes, we are using a function, but this function set will actually run a command for creating the set command to create now our key value pair. So we'll create this and then we read it. So we get the value that we've created from Redis by saying R get using the get function, and we specify the key, and then we store that in product name, and we now when we specify the key, we'll actually get the value, and then once we have gotten it, we store it in product name, and then to be able to get the actual value that we want, we decode it using UTF-8. So run this, and you should get an outcome of example product, which is the value that you have here. All right, so if you go to, again, if you wanted to maybe go to Redis and see what's happening, you could actually do a whole lot of exploration. Let's not even do that for now. Let's just focus on our key objective. All right, so once you have done that, the next thing, assuming that you wanted to update the product names, so instead of example product, you wanted to have it updated, then product name. So we can still again use the set function for that, and we set now the first value, which is now the key, to be the name of the key that we want, and then the value that we want to update, and we just get the product itself, the product that we wanted. So here we have now updated. This is now updated product name. To delete the key, we just use the delete function and we specify the key, and yeah, that's it. If we try to access the key here, we'll get none. Right, that's it. For this particular case, pause the video and then work on this challenge. All right, moving on. We can also store data in what are called sets. So sets normally in Python or Redis would allow you not to be able they would allow you to just store data generally, and also manipulate just data. And there are various things that we could do with them, but in many cases you'll get to realize that you may not necessarily need to work with them all the time. But yeah, to create what is called a new set, we give it normally a key, which is user preferences, and then now the values as shown. So we have the key here, and the same, while it's a key. The same case here, we want to read the values for that particular set. We use just the set name. So this is a key value, not key value, it's a key, but now we would treat it more like we just call it a set, the name of the set itself. So we use sadd, and if you run this, it should work well. Then to get it, we get now the members of that set as shown. I'm using as members, and again we can use the decode function. So decode then UTF-8. So if I am to copy this, decode UTF-8 here. Oh, I won't. I know why. So we'll get actually the items themselves that we have here. we'll get the items that we have there. Let's just leave it at that. Let's not complicate things, because normally when you get the data, you can do a whole lot with that particular data itself. All right, so we can also update an existing element in a set. So we can have, maybe we want to update preference 1, which is this one, with maybe updated preference 1. Use rem to be able to do that, and we technically remove the item itself, which is actually what we're going to learn here. Then we add now a new element. So yeah. And something to note is that, again, a set in Redis, it's almost similar to like a set in Python. You cannot update elements. You can only add or delete elements. That's how we're doing the remove one. So sets essentially. But if you wanted maybe to have something like data structure that you can add and delete and update, you could use strings, or you could use lists. The lists would allow you. They're more like sets, but now they give you that flexibility. So for removing an element from a set is, we use the srem function, and you just pass the name of the set itself. All right, pause the video and then work on the challenge. All right, the last data structure that we're going to be working with for this session, but there are many others, is hashes. And the reason why we would want to work with hashes is because we're going to be learning how to use them to store data from CSV files. So we can store records in a CSV file. So, but generally, hashes in Redis, they are a special type of data structures. It's just a way of storing data temporarily and allowing us to just manipulate that data. And we can store just data, we're using an approach that has fields as well as values. So for example, we can decide to, assuming that we have this user, this user ID, this is the user ID, and the field, assuming that we have this field username, we can give it a value, then another user, same user ID, another field, then we give it another value. So what you have here, the second value is a field, then the value on the far right. And the key is what we have initially over here. So so we can run this to just create new hashes, hash in Redis. And we do that using just hset function. Just executes the hset command in Redis. Then we can do the same thing if we wanted, let's see, to read. So to get now the data for each and every key. So we just specify the key and then now the field itself, and we get the value and store it in the respective variables as shown here. Then we can now specify how to be able to get now those values for individual values. We can use decode UTF-8 and we just get the value for that. The same case for email and followers. We're just printing them out all together, nothing much. And to update, we can decide to update maybe user maybe information such as followers. So here we had followers as maybe 1,000. We can decide to have that as 1,500. So we use the hset function. So you just do the same thing that we did here, and then we pass the key and then the field itself and the value that we want, and then we get the updated data and we print it out. Lastly, we can delete user profile data as shown. So delete, just specify the key and voila, that's it. Pause the video and then work on the challenge. We can use hash, the data structure, to store CSV data so that we can later retrieve it. So for example, if we have this data set, we can decide to store this data in a Redis, in Redis, in a Redis database, but now use the hash data structure. So here we are going to, first of all, convert this data table into a dictionary so that it has a dictionary format. So in our case here we have the request ID 101, And you'll note that for each record we have a dictionary. Like this is one particular case. Oh, where does it end? Okay, there's a lot. There's a lot. Like, for each record, it's a dictionary that we have. So that's what we do here. We convert the data frame to a dictionary for caching. So we have essentially a list of dictionaries. That's what we have there. Then we go through, we iterate through the dictionaries, and then what we are doing, we are creating, defining an F string. And then once we do that, we would cache the data in Redis. So we're just using hset, like what we did here. But now for hset, we are defining the F string that we create here is the one that will represent the key that you see here. And we set the mapping, or hset, that's the mapping, which is what we have here, using now mapping parameter, and we set it to the record itself, the dictionary itself. Yeah, and that's generally how we just cache the data from a pandas data frame, converting it to a dictionary, and then caching that data using the approach, using the hset approach function. Then to retrieve the data, assuming that we wanted to retrieve it, we would get all the keys. So we would essentially use our keys to be able to get the keys. So in any case where we have requests that we had set here, we would actually get all those request keys, which would actually contain, the values that you see here. And then we would iterate through all those keys, getting now the cached data. So for each and every key, we would get now the respective data, and which would be stored here. And then we could then decide to decode it using UTF-8, like what we did in our case here. But here we're just using it efficiently. We're just iterating through the data that we have here. And the output of the decoded data, we append it in this particular list that you see here. Then, which generally here what we will have is just a dictionary, which is just what we are defining here, a dictionary. And then it's as if we are reversing this process of converting data, the data frame to a dictionary. Now we are converting the dictionary to a data frame in this particular case here. And then we just display the cached data. So let's run this, and also run this. It's taking a few seconds. And yeah, so this is the data that we have back from Redis. And generally, that's that's how we're able to just cache data and get it. But if you want also to just delete all the information that we have, so the cache data, delete it completely, we would again get the keys and then use the rdelete function to just delete all the keys, or the key values, and that's it. And we can just check for whether the keys that have been deleted by just trying to retrieve, and you will see that keys after deletion would be 0. Taking a few seconds, and we should be good to go. We don't have actually any. So, all right. So pause the video and then work on the challenge. Now moving on. Now we've gotten to have learned how to work with Redis and Python. Now, if you've understood and you've gone through the challenges and you're good to go up until that point, then you're good now to continue to the next step. So creating data pipelines with Python and Redis. So we can decide to maybe create, maybe extract, okay, let me just explain what we are going to do. We are going to go through just 3 different steps: how to extract data from, maybe you can use how to incorporate Redis during the extraction phase, how to incorporate it during transformation phase, as well as loading phase. So let's start with extracting data. So we could decide to extract data from Redis, assuming that Redis is our database, and store it in whatever place that we want. But for now, what we're going to do to create a pipeline, we are of course going to work with functions, but a pipeline normally has an extraction component a transformation component and a loading component. And you can see for the transformation and loading, we've just decided to make it simple. No complex things here. For extraction, of course, there's something. But here, initially, we decided to have our data. So this actually, you should replace this with your function. So you can always copy what you had initially. So I think what you had here at the very top here, this is what we want. Just copy this and then go to extract data and replace it here. Needs to be just like that. That should be okay. You need to have that information here, so you can update that information manually if you want. Once you have done that, once you have defined this function, this is just for connecting to a Redis instance. Once you have done that, so you now define the extraction function or the component for the pipeline. So here we're going to read data from this particular CSV file. Then once you've read it, we just connect to Redis and we cache that data into now, or store that data into our pandas. You can store that data into a Redis instance. So here we load the data and store it in DF, connect to Redis, and we're just calling this instance, this function, and then we use the for loop to iterate through the indexes. So we are going to have one particular. We can use the same approach that we did use here initially. Where is it? We can use this approach, but here we just, instead of passing, here we passed data underscore dict the entire list, but here we are not passing the entire list. We are passing just the data frame and then using iter rows. So to just iterate through each and every row. So we'll specify the index of that row and the record, and then we get the key for that row, and we just again store the key and its respective records, and that's generally it. So here we're just caching or storing the data in Redis instance, and then once we have done that, we are good to go. Essentially, that will be it. You don't even need to do anything else. But here, what we are doing is just we don't even need to return anything here. We can just we can write return df, but we're just returning what we have here. We're passing it through, but essentially what we're doing is just saying data saved at the end. So that's what we would need to do, assuming that we had data stored in a Redis instance and we wanted to extract data from it. This approach can work, or even the approach that we had also used here could also work. Right? To run this function, you just you again, like in the past, we've gotten through just a few data engineering with different tools. So maybe with other instances, we've created data pipelines and we've gotten to learn how to work with just pipelines, how we execute them. So here we specify that we want to run the extract function, and of course the output would be df. We pass it to transform data. What's transformed, we pass it to load data CSV, and we print out data saved. So let's run this. Taking a few seconds. And that's it. Oh, here we could have just said print. Sorry guys, I forgot. We could have just said print. Something like this, so that we print it out. If you run this again, we'll have duplicate keys. If you run it, no, we won't have duplicate keys. Actually, our data will be updated because HSet will just update it. So here we have data saved. Okay, all right, so moving on, pause the video, work on the challenge, and then we'll continue. In some cases, we might want to work with Redis in the extraction phase. So assuming that we have this instance, so let me copy this code. Again, you'll need to copy this code that you have here. You need to update it to have your own. So assuming that this is our connecting string, this is just a line of code that allows us to connect to a Redis instance. Here we are not focused on extracting, so we just pass just say data printed. Then to transform our data, sometimes we might have maybe some data that we want to extract from somewhere and use it as part of the transformation process. So what we can do is to maybe, you remember that data that we loaded here, the employee data, we might want to maybe use it during the transformation stage. So in this particular case, we just need to connect to Redis in our transform data function. Then we retrieve all the keys that we want, and then we just retrieve the data that we want and decode that data, store it in all data, convert that list of dictionaries into a pandas data frame, then perform some data pre-processing, like convert this particular column into maybe an integer to have an integer data type, then data transform, then we return the transformed data, and that's it. That's what we might end up doing. That's it. Not so much if you know how to interact with Redis. So that's what's happening here. That's it. All right, pause the video and then work on the challenge. Loading data. So once we have worked with the data, so assuming that we had that data that we had, the employees data here that we've transformed, assuming we wanted to now load it somewhere else, how do we do that? So that's what we're going to learn in the next section. So here I'm going to update this function, the connection function. We have our data here. So I'm going to use the same code for transform data. So don't worry so much about here, just using the same code. And assuming that I wanted to load it, I'll just use the concepts that we got to learn earlier about how to cache data. So essentially what we're going to use is just head set. So we are storing data in that particular instance. It's actually the same case that we also learned, the same concept we learned in extracting data. So once we got the Redis df, so here we actually transformed data, and then we got the Redis df, which is actually what we're doing here. We pass it to df, so transform df, we pass it to load data to Redis. So we define our Redis instance, we connect to that instance, and then we load it just as we did in the first example. Here in the extraction phase, we also cached here, but now here we, instead of doing that, we're just loading it. Sorry, we are loading it. So this is a load data. So we are loading it. We are loading the data that we transformed. We are getting it and loading it from Redis. This is Redis df, and updating what we have, and that's it generally. Not much. And almost there. Okay, so should load. Okay, it hasn't finished loading. Let's see. All right. That's it. That's it with regards to how to work with data pipelines. And you'll note that we have this code. Like the way this code is, you can always just store it in a .py file and just use a tool like cron job to just be able to automatically run the code whenever needed. All right, that's it with regards to this learning experience. If you did love how we were able to wait, before I do that, you can always work on the challenge. There's a challenge just to be able to reinforce the concepts that we've learned. And yeah, so just work on the challenge, pause the video, work on the challenge, and then we'll talk about the next steps. Right, so in terms of the next steps, what would we recommend? So far we've gotten to have learned about Redis in this workshop. In the past, we've covered other types of data sources. So if you wanted to create a data pipeline that pulls data maybe from MongoDB, there's a workshop on that. This same case with Postgres or other data sources, could even be MySQL. So our recommendation is that you need to look towards working on maybe a different type of data source that works differently. Like our next session will be on Cassandra, how to work with Python and Cassandra, because data is stored, it's usually stored differently in Cassandra, and just to be able to just have an idea of what types of solutions you can develop. and how efficient you can develop them. Because sometimes if you don't have an idea of how to work with these different data solutions, you may not necessarily have in mind the clue to implement efficient technologies in your line of work. That's what we would recommend, as well as just projects. Just build a few data pipelines, think about what maybe might be useful in your case, maybe as a project, then implement that, post it on GitHub, and voila. That will be a good project for showcasing what you've done in the past. Right, so that's it. That's it with regards to this learning experience. All the best in your learning journey. If you did find this learning journey beneficial, valuable, be sure to give this video a thumbs up. It tells us that we are doing a good job, and it also helps other people who might be interested in the same learning experience get to be recommended of the same. And if you'd want to be informed when we post such future learning experiences, be sure to subscribe, and all the best in your learning journey. See you in the next